Welcome to qnawire.
All right, so in this problem, we're going to take a look at the relationship between mass and weight for a number of everyday objects. This is also an exercise in unit conversions. So we're told that a flea typically weighs 210 micrograms, but we do want things to be in SI units, so namely kilograms, so that when we multiply this by an acceleration, we end up with something with units of newtons. I'm just going to go ahead and do the unit conversion right off the bat. And so you can obtain the weight of something by multiplying its mass by the gravitational acceleration near the surface of the Earth, which is 9.81 meters per square second. Plug that into a calculator and then get that the weight of this bad boy is 2.06 times 10 to the minus 6 newtons in scientific notation. So in other words, 2.06 micronewtons, very, very tiny, which we'd expect for a flea. Part B, the object of interest, is now a frog hopper. So they give this to us as 12.3 milligrams. However, just like before, this would be more helpful if we expressed it in terms of kilograms. So we're going to do that unit conversion right away. And then same formula, same exercise. Weight is equal to mg. So it's going to be 12.3 times 10 to the minus 6 kilograms. Multiply that by our gravitational acceleration, 9.81. Then get that the weight of a frog hopper is 1.21 times 10 to the minus 4 newtons. So bigger than that of the flea, which is what we'd expect, but not even a single newton. So still quite tiny. And then lastly, in part C, we're doing a house cat. And it's a little bit different because they tell us the weight in newtons. And so that is our starting point. Again, a little bit different for this problem. So we have the weight, and we're told that it's 45 newtons for a cat. And then they want us to know the cat's weight in pounds, and then what is its mass in kilograms. So we're actually going to have to do a real unit conversion of this problem. So look it up in a table, but there are 0.225 pounds in a single newton. So that's our conversion factor here. Multiply it through, we see that the newtons cancel out. And then put that into a calculator, and we see that our weight is going to be 10 pounds, and that's two significant figures. And then lastly, we can obtain the mass of the cat by dividing that original weight in newtons by the gravitational acceleration in meters per square second. So we said that this was 45, and this is 9.81. So put that into a calculator, and then, sorry, my mouse isn't working, and then your mass is going to be equal to 4.6 kilograms. And we're done.